In this video, we will illustrate graphical displays of single variables. So first, we're going to open our dataset in Jamovi and then see what we can display about these variables. The displays of individual variables are a part of the descriptives. So again, we go into analysis, exploration, and descriptives. Let us begin with the three variables that are categorical or qualitative measured at the nominal level. We do not want the statistics at this point, so we can uncheck these, and then the whole result disappears. We saw that we can get frequency tables in terms of descriptives, but we can get similar information graphically if we go down here and open the plots section. The only thing we can use for categorical variables are bar plots. And this is the only good use of bar plots. Please don't use bar plots for anything else. In this case, where you only have two labels, they're not terribly informative over the tables. But if we had lots of different labels, or if we had ordinal level variables, it might be informative to actually produce a graphical display. So we can scroll down and look at the proportions of different values in our three variables. So we can see that there is about the same number of children in the two conditions. There are many more children with a majority home language than a minority language, and there is approximately an equal number of girls and boys. Some people like to get pie charts, which are kind of horrible, but Jamovi doesn't produce them because they're not really used outside of newspapers. If you really want to produce a pie chart for one of your variables, you can use this trick. Go click on RJ Editor, delete this thing which we don't need, highlight and delete, and then type pie, open parenthesis, table, open parenthesis, data, dollar, sex, close parenthesis, close parenthesis. So this instructs Jamovi to only use the sex variable from your data. That's what the dollar is doing there. Produce a table of values from that variable, and then produce a pie chart from that. It's very important to have one parenthesis opening here, one opening here, and both of them closing there. There are two sets of two instances of closing parentheses there. And then click on the green triangle to run this, and this is the result, which looks very silly as expected. To delete something you don't want from the report, you can right-click on this one and then go on and click on remove. So we can forget this as if it never happened. What about graphs for the numeric variables? Analysis, exploration, click on exploration, click on descriptives. So we start a new section of reports. Since we're not going to be asking for any descriptive statistics, we uncheck these so that section disappears. And then we select which variable we want to see graphically. Let's run our examples first on the matrices 0K variable. Let me close the statistics section by clicking on it and make sure the plot section is open. If it's not, you click on this. So the first thing that we always look at when we have any quantitative data is a histogram. At any point, you can add variables, and this will automatically produce the same graphs for the other variables. So I can now add the vocabulary variable here, and it will immediately produce the histogram for the vocabulary. In addition to the histogram, I can plot the density. The density you can think of as a line that tries to go through the histogram as if smoothing the tops of the different bars. And here it's kind of in the middle because it has to be smooth, and it has to be between this low value and this high value. And similar things go on here. So you can even make the histogram disappear and only retain the density, which we don't do because the point of having the histogram is to see where your actual data are. And the density hides your data and only retains the shape. This is useful in some situations, but not when you want to examine the data for possible problems. So this is the basic graph you should always produce with all your numeric variables. Another very useful graph is the box plot. To understand how the box plot works, let me first plot the data. So you can see here, these are the actual values for the matrices data. They're just scattered here, and this tells us that there's 3 values around 10. There's a bunch of values between 15 and 20 something, and there's a few values around 25. So these are the actual data, like these data. One way to look at these data is called a violin plot. And the violin plot is showing you how much data you have around each region of values. So it is not a coincidence that the violin plot looks like a symmetric version of the density. So these are the same values for the same variable here and here. So the violin plot is basically your density line, which is derived from the histogram, except it's plotted vertically, and it's plotted both left and right. So if you didn't have the data plotted, this would tell you in what regions of values your data would be concentrated. What are usually plotting, though, is something much more straightforward, and it's called a box plot. This is the box plot, and indeed it's called like that because it contains a box. The box is the 50% of your data, the central half. Remember when we were discussing the interquartile range, that we split the data into 4 quartiles. So this is what you're looking at here. The black line is the median. This line is the first quartile, and this is the third quartile. So within this range, half of the matrices values will be found. So if you were to count the number of points in here, they would be as many as here plus here. And these lines extend to the range of the data. So they go from the minimum to the maximum. In some cases, a variable will have outlying values that will be far from the central data. Let me add the vocabulary measures at grade 1, in which case you see here there is a value that is a bit outside of the distribution. And so in this case, plotting this box plot to the full range would require this line to go all the way up to here. Let me remove the data and only show the box plot. So the box plot, in the case of such data that are potentially outlying, that would cause extremely long lines only plots the line up to some point, which is 1.5 or twice this width, and the rest is plotted individually so you can see how many possible outliers you have. The box plot is one of the most useful plots you can get, especially when you want to make comparisons. The first and most important plot is the histogram, where you check the distribution, its shape, and potential problems, and then you can use the box plots for further comparisons.